Thank you for giving me the floor. My name is Florina Piroi. I have a double affiliation, actually. I am co-founder of the Artificial Researcher IT, which is a startup emerged from research done at TU Wien, where I am back since this March. I'm going to present you now a very concrete case of working with data towards making it, let's say, interoperable or semantic and so on. So the AR Science project and the AR Science, the whole set of tools we are working on in Artificial Researcher concentrate on language technologies, and we are working with raw text and make an enriched data set, which we afterwards want to build further down the line tools for efficient search. So I'm absolutely confident that every single one of you has been looking for documents. You probably use some kind of interface where you typed in some queries, and ideally you have the first 5 documents in the list of 10 results are extremely relevant for you. You might also have worked with some very advanced way of navigating for information or searching with some graph representations. But how do you get from these text documents, which are really lots and lots of PDF files in whatever format? You might have XML files scraped from the web and so on. How do you get to these nice research, nice search interfaces, and especially efficient ones? So search engines, they work with indexes. And indexes are, let's think of them, some kind of very smart dictionaries. And dictionaries are, again, pairs of information and linked data to them. So you can very well represent them in some kind of triple-like, graph-like, and so on. So indexes can be represented also as ontologies. Now, to create such indexes for a search engine, or for an exploratory system, or for a navigation system, you actually need to start looking at the data and extract these things and put them in a form which is useful for your search system. So we work with 2 types of information. So we look at metadata, and we also process full text. Now, metadata, especially for documents, for scientific articles, we concentrate a lot on scientific articles, is very rich in bibliographic data. You have names, you have institutions, you have authors, you have collaborations, yeah. Then you have references and citations. You really want to have that so that you can explore your network of collaborators, maybe, or you're looking for project partners. You really want pertinent information shown to you. You want to detect resource sharing. Which data was produced in which project by which authors and so on. This is extremely difficult actually to gather and bring into one interface. Then you start looking at full text. You have these documents. How can I be sure that I don't get this document back just because it mentions research in the abstract? You know, I mean, and this was by mistake the keyword I was looking for there. Well, we look at identifying specific terminology for your queries, for your information need, and this is also completely not trivial if you work with scientific documents, with technology, technical documents. Then you also want to identify the scientific discipline. Is this about computer science? Is it about AI? Is it about, I don't know, farming? Is it about security? How do I classify this document I have in my collection? You also want to identify the relationship between terms. And you want, of course, when you are searching, maybe you don't want to look at the all articles, you only want the very specific paragraph of that document, and this is extremely relevant for patent searchers and professional IP searchers. If I think of my own work when I'm looking at an article, I would rather have a system to tell me, you know, this article claims this. It used these methods, and these are the results. You know, without me reading all 10 pages, but maybe one summary of 2 pages. Good. So what do we do? Yeah? How do we get from this text, this bunch of things, to something like this, which we can actually exploit and gain knowledge out of it, interesting stuff. So we work with scientific documents, research articles. We have the core UK collection, for example, the biggest of open access scientific articles available out there, and with patent documents, which are very, very complicated documents in terms of language genres they use there and so on. And also, they are very complicated because they introduce a lot of new technology, and you want to know about it, and you want to place it in your knowledge network. Where is it? So we are able to get from here and extract this kind of information and have it connected. I mean, these are very basic representations, which are just illustrative. And we also are able to create this kind of graphs here, which is actually a lexical ontology. And I want to explain you this a little bit because you try to extract information from a text and put it in an ontology. I can tell you that I work on a project right now where they discuss since a year how to put the processes, only 2 processes selected for that specific project. They discuss since a year. Is this a relationship of this type? Is it the function? Is it a concept? Is it so a year? So you can't do that automatically without extremely good domain-specific persons to be there with you and talk to you daily. So what you can do automatically to some certain level, and it works really, really fine, you can extract this type of relationships. I am able to detect that farm animals is a generic term for pig, sheep, horse. I am able to say that a pig is a farm animal. So these type of things we can extract to a certain level from all these documents. I mean, this is a very simple example, an illustrative one, but we are working, of course, with more complicated terms, like butane, and this specific term here has attached a label to it, liquefied petroleum gas. And once we detected these terms in the document, we started looking around, actually not started looking around, but we pick our additional sources to enrich this data. We look specifically at Wikipedia information for what's open there. And then we also connected with other classification taxonomies and so on, in this case, the International Patent Classification System. Good. So this is now more or less our assembly line. So we start with these documents, patents, scientific articles, and we have our natural language processing tools which pick up things and do a lot of very interesting and fascinating stuff. We need to do text normalization, harmonization. We have we try to extract all this metadata, and we push everything using also additional extra language resources. We push everything into a very nice repositories here, and then we unify everything into a larger index. And once you have this, you can actually use it and implement something like that. So now, just to explain you what goes into that final repository. This is for one concrete case where we looked at some chemical thing, and this is now an information extracted from a collection of documents we worked with. And if you look at these 2 terms here, these are hexyl and alkyl, and you click on the relationship between them, you click on it, and this is all the information we managed to somehow automatically create. And this is now semantically enriched. You can build, you can pass it on to other tools. You also have direct links to the source of the information. This is now the original text where all this was done. And in one use case we have in our startup is that for patent experts, we actually help them expand their query in an automatic way. But you don't just expand it just like that. You don't want to add just any word to this, because they are very good friends with Boolean searches, and then you're just getting everything. You get basically the whole collection back. You really want them to be as generic as possible, but also very specific to that area they are looking for. So this is what we do automatically. Of course, you can use it with a backend and so on there. What actually I want to underline is that using this type of semantical relationship detection and enrichment of the data often works very much better than just throwing it to a neural network, which is now the hype of the day. And it's often some neural network methods would not even recognize that this is actually quite relevant to a brake pedal, to this concept. So if you are looking for prior art for an application, then you want to find also this one. Another system would not give it to you because this similarity score is very low. They usually look for similarity score 75, 85, 90%. Using the same methods, which I explained, finding terms and connecting them and so on, we are also able to go cross-domain. So we tried our work on COVID data, so scientific articles about COVID data, and we connected them to patent collections, which is also, again, extremely important because patent experts need to be aware of the research that's going on, and they are not connected to the research literature. They are they have difficulty times finding them. So we tried our all this work in various projects, and then one of them just closed last month. It was funded by the Vienna business agencies, and yeah, pain points, really big pain points: data quality. Often with all this integration I showed you, linking to this or that, this was done by hard work because all these data sets we used were not really described. They were not machine actionable. They were really, yeah, here it is, take it. Thank you. Wrong content, OCR, so data quality, cleaning it, it's really, really a huge part of our work. Thank you very much for your attention.